This is Algebra 2 at Trig, 2B.7b. We're just working on solving by using any of the methods that we see fit. So I would encourage you to pause the video and look over the first three questions. What method would you use? You might be able to add and take the square root, or you could factor it. Here you could factor it or use a quadratic formula. Here you could factor it or use the quadratic formula. You don't need to use synthetic for every type of problem. So give this a try. So we look here at the first one, and we notice that this is the difference of two perfect squares. So x minus 3 and x plus 3 would be how we could factor that. It's got to be equal to 0 still. When it has an equal sign, that tells us that we are looking for zeros. We're trying to solve. So x minus 3 equals 0. X plus 3 equals 0. This is called the zero product property. And we get our two answers. These would be where this parabola would cross the x-axis would be at 3 and negative 3. This next one, again, it's a quadratic. We're looking for two answers. Looking for two numbers that multiply to be 24 and negative 24 and add to be 5. So if you had a positive 8 and a negative 3, you would get negative 3 plus 8 would give you a total of 5. That adds to be 5. And the 8 and negative 3 multiplies to be negative 24. Just foiling that out. So x plus 8 equals 0. X minus 3 equals 0. We have our two answers. Six x squared minus 3x minus 8. Got to move the 8 back to the other side of the equal sign. You need to make it equal to 0. Now there's a couple different ways we could do this. We could use parentheses for factor by grouping. We could use parentheses to factor by guess and check. Or we can use our table. What multiplies to be negative 48 and adds to be negative 13. We know our two signs have to be different if they're going to multiply to be negative 48. And the larger number has to be negative if it adds to be a negative. So 1 and negative 48. 2 and negative 24. 3 and negative 16. Hey, 3 and negative 16. That makes negative 13. So those are my two numbers I'm going to use in factor by grouping. Positive 3x minus 16x minus 8. You place those numbers in the middle between your a and c term because they represent the negative 13. And factor by grouping. What's your GCF that comes out of the first group? Bring down your sign. What's the GCF that comes out of the second group? A negative 8 and a positive 1 makes a negative 8. That's a common mistake. Notice that the parentheses are exactly the same. They have to be exactly the same. If they're not exactly the same, then factor by grouping does not work. So you're factoring out the 2x plus 1 because both of these groups, on the left side of the negative and on the right side of the negative, they both have a 2x plus 1. So we're factoring that out, and that leaves us with a 3x and a negative 8 together. So if you did the zero product property, you would add 8 and divide by 3. You would subtract 1 and divide by 2. So those are two more answers. Coming down to our next group of questions. Notice that for number 5, this says x to the 4th minus 10x squared. That's got to be a square for it to work out smoothly. Give the next 3 a try. Pause the video. Try it on your own. See what you do. These you might get some imaginary answers. So we're looking at number 4. Number 4 can be, if we're thinking about trying to solve these by factoring, that's kind of our current process here. Then we would do our zero product property. Neither of these are difference of 2 squares. 6 isn't a perfect square, so I wouldn't factor that apart again. Add the 6 and take the square root. And I get plus or minus the square root of 6. But on this side, I get plus or minus the square root of negative 6. Which we should use the I to represent when I subtract the 6 across. Let's see if I can get that crammed in here. There you go. You subtract a 6 across, then you would take the square root and you would pull the I out. Now what that looks like on a graph we go to y equals x to the 4th power minus 36. It's going to go way down low, but you see that it only touches at 2 spots. We know that this graph is going to go way down and touch at negative 36. So I'll say negative 40 for my y minimum, so we can see that whole graph come down, curve, and go back up. So it's just like a parabola. Very much like that. But we only have 2 answers. The other 2 are considered imaginary because they're not real. We only have 2 solutions for this. Here we had x to the 4th minus 10x squared equals negative 24. Because we have 2 different types of x's, we need to bring everything over to the same side of the equal sign. We don't have any special form, special way to factor x to the 4th. No special way there. So we're just going to treat it like a quadratic. That makes x to the 4th. What multiplies to be 24? Well, there's a few things that do. Right? 2 times 12, 8 times 3. But it's also 6 and 4. Would have to be negative 6 and negative 4 to multiply to be positive 24 and inner to be negative 10. X plus 2, x minus 2, because that's the difference of 2 squares. So factored it completely. Use the zero product property. Add the 6 and take the square root. So you're going to get plus or minus the square root of 6. Just so you can get used to seeing what some of the answers are like. What do they mean? I did not use my calculator to get the answer, but I'm using my calculator to check my work. In homework, that's very appropriate. Notice it comes down and it touches, so I'm going to go back to my normal standard, and you see that it's touching in those two spots. So one of those spots would be -2, the other spots would be +2. +2 gives me a 0, -2 gives me a 0. The other two spots would have been the square root of 6 and -6. All right, number 6. There's probably different ways we could think about doing this one, but what would match what we've been discussing is to bring the 54 across. I see that this is an x cubed, so that starts to give me a hint on what I should do. This is x cubed. So it can't be done like that. Can't be done like that. X cubed is going to give me the hint that this could be the sum of two cubes. But I can't take the cubed root of 16. I can't take the cubed root of 54. But I can factor out a 2. And that leaves me with the sum of two cubes. 2x plus 3. And then you square your 2x to get 4x squared. Change your sign. Multiply the 2 and the 6 together. And square the 3. That's how we factor the sum of two cubes. Cube root of 8 is 2. Cube root of 27 is 3. 2x times 2x. 2 times 3. And 3 times 3. So, using the zero product property, of course, we would get -3 over 2. You would subtract the 3, divide by 2. This here, since this was the sum of two cubes, this will never be factorable. You won't be able to factor that. So you can spend a few moments thinking about it, but it's not going to factor. So if it's not factorable, we can use the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I believe this comes out to be 6 plus or minus the square root of 108 over 8. So I believe that comes out to be 4 times 27. So that's 6 plus or minus 2 root 27 over 8. And you can reduce a little bit here. This would be 6 over 8, which would be 3/4. But this would be 2 over 8, which would be 1/4. Oh, and 27 can be broken down, can it? That would be 9 times 3, which would be 3√3. That doesn't help me reduce anything except the radical. So that would be your answer for up here. There's a little breakdown-ish. Okay. Go ahead, pause the video, work your way through 7, 8, and 9. Here you might start to use synthetic sum. So here I notice I have 4 terms. So I'm going to try to see if factor by grouping will work. And because of what's inside my parentheses is exactly the same, looks like I have 1 real answer and 2 imaginary answers. That's a total of 3. Here, when we look at this, we have 4 terms. I brought the other 2 over to the left-hand side. Factor by grouping would not give us the same thing. We wouldn't get the same thing inside the parentheses. I would pull out an x squared and get 2x, but I'd nothing to pull out here. I still have an 8. So I cannot use factor by grouping there. So we would need to type this into our calculator. And notice where it crosses the x-axis. Alright, 1 second. Let's be sure I typed that in there correctly. 2x cubed plus 3x squared minus 8x minus 3. Yes, when we add the 3 across, it would be a positive 3, so that positive 3 would have to be there. Now when we graph it, you see that it's going to go through some more nice clean answers. There it is. Negative 3 is at 0. So if we use negative 3, multiplies to be negative 6, multiplies to be 9, multiplies to be negative 3, so I get 0. So x plus 3 is a factor, and 2x squared minus 3x plus 1. So that's going to give us negative 3 as a solution. And this should be able to factor apart. 3 times 1, or 2 times 1 and 1, negative and negative. So that's going to give us 1/2 and 1. So looking at number 9, I see an x squared. Alright, so what multiplies to be 2 and adds to be 4? Nothing. So I can use quadratic formula. Remember, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. That's your quadratic formula. And I can use that to solve a quadratic. Even if it's factorable, I can solve for x using the quadratic. Factoring is just usually considered quicker. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's negative 4 plus or minus 16 plus 8. That's 24. And 24 can be broken down. That's 6 times 4. So the square root of 4 is 2. So that's 2 root 6. So we can reduce on both sides. You have to be able to reduce on both sides. So there's your answer using the quadratic formula. And our last one. Whoa, this is x to the 4th power. This has all these terms in it. I don't have a method other than synthetic. Okay, my possible zeros are going to be plus or minus 1, 2, 3, 4, 6, and 12. Oh, that's nice. No fractions. I can type those in. Messed that part up. Let me start over. Let's try that again. Try to type it in here correctly. X to the 4th power plus 5x to the 3rd power minus 4x squared minus 26x plus 12. I can go to zoom number 6 and zoom number 6 and it goes back to normal. Maybe be able to see it go through these a little bit better. I see that it's going through -3. So in my table, I bet -3 says 0. So that tells me -3 is going to be a good number to use. So I use my coefficients, drop down the 1, multiply, and I get 0. And we have a little smiley face. We're happy about the 0. So x plus 3 is my factor. And x cubed, 1 less than the x to the 4th, x cubed plus 2x squared minus 10x plus 4. That's my leftover cubic. This times that should make our original problem. I can go back to my graph. It looks like at 2, when x is 2, I can go to table and look where x is 2, and I get 0. So I don't have to retype in my new equation. I can still use my old equation. Oh, you don't need that. We're going to use 2, we said. So 2 with the 1, 2, -10, and 4. Hey, that gave us 0. We're not surprised. So we have x plus 3, x minus 2, and x squared plus 4x minus 2. This one, it does not factor. You can't multiply to be -2 and add to be 4. So we'd need to use a quadratic formula. It might look familiar to you. So we get -4 plus or minus the square root of b squared minus 4ac all over 2 times a. That's -4 plus or minus the square root of 16 plus 8, which is 24, all over 2. -4 plus or minus 6 times 4. 6 times 4 brings the 2 outside. and that we can reduce on both sides. Negative 2 plus or minus the square root of 6. So those are two answers, and I have my other two answers here. Now you should be able to take, let's just try this. You should be able to take negative 2 plus the square root of 6, 0.4494. If you take your graph, I bet that's 0.4494. Second trace, go to the 0, get close to it. .4494. So it'll give you all those answers. This is the exact answer. This is the better answer. We're not using our calculator to get the answer, but I'm just testing to see if my answer was accurate.